in this video, we're going to go over some of the rules that we can do with negation, double negation, modus delendo tollens, and also indirect proof. Let's get into it.
The first rule that I want to look at here is double negation. Now, double negation is a rule of substitution. This means, like, in this situation, you can go backwards and forwards with what we're going to get. So far, all the rules that we've done have been rules of inference. What that means is, if you have a certain criteria, then you can pump something out of it. So like if you have, like with arrow out, if you have an arrow, you have the left side of the arrow, then you can get the right side. But you need those special conditions to make this happen. Double negation as a rule of substitution is something that we can really always use as long as we have something. So let's talk about a ridiculous example of when we can use it and how it works. So let's say I had A as an assumption. And let's say A stands for it is possible. Whatever the it is we're referring to. Let's just say A stands for it is possible. At any time that you want, you can put a double set of negations onto that, and it means the same thing. Now that doesn't seem like it'll be useful, but it will be, and especially it'll be more useful in reverse. So what that means is, if I have it's possible, I can just slap really any even number of negations onto that. So if I've got A, I can say I've got squiggle squiggle A. How? Double negation line 1. So this is kind of silly, but here's what this means. If I've got it's possible, it's the same thing as saying squiggle squiggle A would be the same thing as saying is it's not, okay, not means not, obviously. It's not impossible. And sometimes we'll do this in English for emphasis. So squiggle squiggle A. Okay, if I say it's possible, that's the same thing as saying it's not impossible. Why would I do this? Well, if I told you solve, if you have A, solve for squiggle squiggle A, that would be the perfect time to do this. But that also means I can do this in reverse. If I had just squiggle squiggle A, so you had an assumption, it's not impossible. I want you to prove that it's possible then. Oh, I can say, hey, line 2, A, double negation, line 1. So here's the deal. The way double negation works is as long as you have an even set of squiggles, it's always the same thing as having no squiggles. So look at this. Even if I had not A. Okay, that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have an even number of squiggles, okay, it's the same thing as having no squiggles. Okay, double negation on line 1. On the other hand, if I had an odd number of squiggles, no matter how many, if I had, let's say, 11 squiggles, it's the same thing as having 1. Okay, so if I had not A, well, basically these cancel out, 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 but this one's left. So if you have an odd number of squiggles, the one that's remaining still pertains. So if I had 11 nots A, it's the same thing as saying not A. We do that. Well, I didn't not do that, like that kind of language you might use here. So double negation works either way. So the reason why you might want to use it is in this situation. Let's say I said you had B arrow, squiggle squiggle A. You've got B. These are your assumptions. And I want you to solve for, well, get A by itself. So can we do an arrow out here? We can. That would get us squiggle squiggle A, arrow out, 1 and 2. But is this what I want here? Is it A? Well, logically, yeah. Is it exactly that? No, it's squiggle squiggle A. Can I convert this into something else? Yes. Here's what happens here. I can say, hey, I can convert this thing into just plain vanilla A, double negation, line 3. And that's when double negation becomes useful. When you need to convert something, you have the ability to do so. And those conversions are basically the same thing as converting between it is possible to it's not impossible. And like I said, in English, we actually use those things to offer a different kind of nuance. Like, will we win? It's not impossible. Well, coach, why didn't you say it's possible? I could have said that, but I was saying this to say it's not impossible. It means something a little bit different. Logically, it's equivalent, but in English out loud, or even in writing, it has a little bit of a different nuance. Okay, the logical syntactic meaning is identical. But we will say things like this. You can't not do that. Well, so can I do it? Well, yeah. But there are other dialects of English, say African American Vernacular English or AAVE, where saying a double negation does not in fact mean double negation. So if I said something in AAVE like I ain't do nothing, that doesn't mean, oh, I did something. That means, no, I really didn't do anything. That's what it means in that particular dialect. And so depending on the dialect of English that's in place, these rules may not apply. But at least in standard English, double negation functions in this way. So let's translate a few statements where we got some negations going on. So I might say something like this. It's false that the governor is both in Greenville and Charleston. So let's translate a statement like this. It's false that the governor is both in Greenville and Charleston. All right, now, what's false? The governor is in both Greenville and Charleston. So, can the governor, he's in Greenville, the governor, and he's in Charleston. Is he in both those places? No. So that's what's going on here. It's saying this. The governor, he's in Greenville and Charleston? No, he's not. He can't be in both those places at once. So that's what's going on here. Whereas, if I said it's false that the governor is in Greenville, and it's false that the governor is in Charleston, that's actually something different. So this would be, it's false that the governor is in Greenville. Okay, he's not in Greenville, and he's not in Charleston. All right, so this says he's not in Greenville and he's not in Charleston. Maybe he's somewhere else. This says, on the other hand, it's false that the governor is both in Greenville and Charleston. So this is saying he can't be in both these cities at the same time. They're too far apart. He can maybe be there in the same day if he takes a drive, but he can't be there. Is he in both these places at once? No. This is saying he's not here and he's not here. Maybe he's in Columbia. Okay? Or maybe he's anywhere else. Okay? He's in Batesburg. All right, he could be anywhere. This is saying he can't be in both these places at once. This is saying he's not here and he's not here. So keep that in mind too. So if you see it's false that both, it's saying that two things together as an and cannot go together. Can someone be in Greenville and Charleston at once? No, they cannot. That's what this is saying. Can he be in two places at once? No. This is saying he's not here and he's not here. Two different things. This is something you might see in the headline of a newspaper. Drought conditions remain without precipitation. And there, without is doing the work of unless. It means the same thing as unless. So I can replace this with drought conditions remain unless there's precipitation. What does that mean? Well, whatever follows without, in this case, or whatever follows unless, goes on the left side of an arrow with a not in front of it. Okay, so what's following without? Precipitation. What do we do when whatever follows unless? We stick it on the left side of an arrow with a squiggle in front of it, and then whatever remains goes on the right side of the arrow. So what this is saying is, if it doesn't rain, then the drought conditions are going to remain or continue. So this is another example of what we do with something. Again, without here means unless. It's really the same thing. This can pop up as well. Now, we've talked about a couple of examples of negations. We've talked about double negation. Let's look now at modus tollens. Modus tollens. The abbreviation for this is going to be MT. Now, we talked about modus ponens. That means mode that affirms, or modus ponendo ponens, mode that affirms by affirming. Modus tollendo tollens means mode that denies by denying. Okay, so it's very similar to modus ponens, but we're going to have to do something different here. So here's the way modus tollens works. It says this. Okay, if you got an arrow, and you've also got the contrary to the right side. If you have these two things, then you can get the contrary of the left side of the arrow. How? Modus tollens? 1 and 2. Well, let's take a look at an example in an argument, and then we'll see how modus tollens works. This argument says this, so I'm going to translate it as I go, and then we'll see how it's an example of modus tollens. This says, if Sauron requires the one ring, okay, that if means there's an arrow. So arrow this, okay, arrow. Line 1, whatever follows if goes on the left side of the arrow. If Sauron reacquires the one ring, so if he gets the ring back, then he'll regain all of his former power. If he gets the ring back, he'll reacquire all his power. Assumption number 1. Okay. Assumption number 2, he has not regained all his former power. Line 2, his power, does he have it? No. Assumption number 2. So modus tollens tells us in this situation, got this. If he gets the ring, he'll get his power back. He doesn't have his power back. What does that mean? He has not gotten the ring. So I can say squiggle R, modus tollens 1 and 2. So here's what's going on here. If you have an arrow, so this is kind of like arrow out, it's a little bit different, but it's kind of predicated on the same notions. Modus tollens works this way. If you got an arrow and you have the contrary of the right side, again, colloquially we can kind of say the opposite of the right side. Technically that's not true, so I'm going to keep using the word contrary. So look at your arrow. Look at the right side of the arrow. Do you have the same thing but with a squiggle in front of it? So look at the right side of the arrow. This is the way modus tollens work. Modus tollens works. Look at the right side of the arrow. Look what you got. Do you have the contrary of the right side? If you do, then that means you can get the contrary of the left side, which would be whatever this is with a squiggle in front of it, or vice versa. We'll look at a couple examples of that in a moment. So whereas modus ponens, or arrow out, says if you got an arrow and you got the affirmation of the left side, you can get the right. Modus tollens says if you've got an arrow and you look at the right side and you've got basically the contrary of the right side, then you get the contrary of the left side. Again, you can use the word opposite there instead of contrary. That's technically not precise, so I'm going to try and avoid using it, but I'll do it one more time that way. If you got an arrow and you look at the right side, you got the opposite of the right side, you can get the opposite of the left side. Technically, it's not opposites. It's contraries. That's I want to stick to that point, but nevertheless, that's how modus tollens works. So you got and even if we did this with the A arrow B, let me put it this way. Same thing. Let's say I had A arrow B. If you work, you get paid. You work, you get paid. Let's do it modus tollens style. You work, you get paid. Oh, you didn't get paid. Well, guess what then? You must not have worked. Modus tollens. Same kind of argument. Now, there are a couple of formal fallacies where these get mixed up. You can't say, oh, I have the opposite of the left side. That means I have the opposite of the right side. And you can't say, oh, I have the right side. That means I have the left side. Neither one of those works. Those are both fallacies, formal fallacies. Affirming the consequent, denying the antecedent. Neither one of those work. But modus tollens works this way again. You've got an arrow. Look at the right side. Do you have its contrary? Yep. P and not P are not friends. So if you're saying this leads to this, and you don't have this, well then you must not have had the first thing in the first place. And that's the way modus tollens works. Now I also think it's important to say at this point that negations stick with the stuff that we've already been doing. So if I say something, for example, like if it's not Wednesday, then we don't have class. Let's say I said something like that. If it's not Wednesday, then we don't have class. Okay, let's say it's Wednesday is W and we have class is C. This would be squiggle W, arrow, squiggle C. But then let's say I said, oh, it's not Wednesday. Second assumption. And what do we know? Well, do we have an arrow? Do we have a left side match? We do. Now here the left side match is bigger. So we had squiggle W. Do we have a match for that? Yeah, we've got squiggle W. That means we get squiggle C. That is still just arrow out, line 1 and line 2. So we have an arrow. The left side here is bigger. It's squiggle W. Its left side match is also squiggle W. So now here we can include the squigglage in terms of the matches. All right. If we just had W, that wouldn't work. It works here. Based on the same features here, if I said something like it's not Wednesday and we don't have class, well, those things can break down too. Let's say I had that. I've got a dot. I can break that apart into two things. If I said today's Wednesday and we don't have class, hey, it's not Wednesday and also we don't have class, and that's and out here for both. The not stays around, so the not modifies, or the squiggle modifies things that we've already been doing since quiz 2. The final rule that I want to talk about is the notion of an indirect proof. So indirect proof is another emergency situation, kind of like arrow in on the last quiz. So what we do is we see, can we do arrow out? Can we do modus tollens? Can we do and out? Should we do and in? Should we do double negation? And when we ask those questions, if the answer is no, then what we do in that situation is we're going to provisionally assume the opposite or the contrary of the goal. We're going to get a contradiction, any contradiction. What is a contradiction? While contradiction is an and statement, it's a conjunction of something and not that exact same thing. So that's what a contradiction is. It's a something and its contrary. Or we could say more colloquially, and its opposite, but that's not quite accurate. That's why I want to avoid saying that. So let's take a look at this problem, and let's put this into practice here. Let's say we had something like this. Let's say we had squiggle A, arrow B, as an assumption. And we've got squiggle A, arrow, squiggle B as a second assumption. And we want to get plain old A by itself. And in fact, this is actually 3A out of your book on page 72. We got these two assumptions. We want to get this. What do we do? So let's go through now this new modified list. So our new list is this. Can I do an arrow out? If so, do it. Can I do a modus tollens? If so, do it. Can I do an and out? If so, do it. Can I do an and in? Should I do it? Do it. Can I do a double negation? Should I do it? Let's take a look at this. First of all, do I have any arrows not in parentheses? Let's do the first thing, arrow out. Do I have any arrows not in parentheses? Yep, I got two. I got this one, and I got this one. Now, the left side of both these arrows is squiggle A. Do I have a squiggle A anywhere? Do I have a left side match? No, I do not. Moving on. Modus tollens. Now, modus tollens says, hey, if you got arrows, look and see, do you have the contrary of the right sides of your arrows? So now let's look at this again. Okay, what I want to look for, here's my arrow. Do I have the contrary of the right side? So look, this first arrow, I've got B. Now the contrary of B would be not B. Do I have a not B anywhere? No. Look at this arrow. The contrary of squiggle B would be just plain vanilla B. Do I have that anywhere? No. Alright, so modus tollens is not happening. Do I have any and outs? Or do I have any dots anywhere? Not in parentheses. Nope. Can I build anything together with an and in? Yeah, I could put these things together with an and in. Does that get me anywhere? No. Double negation. Can I add double squiggles anywhere? I could. Like I could turn line 1, I could say line 3. Line 1, squiggle A, arrow B, double squiggle that. Could I do that? Perfectly fine. Doesn't get me anywhere. So what I find myself in is a situation where I'm kind of stuck. Now, before we would say, all right, now at this point, try arrow in. All right, is my goal an arrow? My goal is A. Is it an arrow? No. So can I provisionally assume the left and get the right? No, I can't, because my goal is not an arrow. So that leads us to this situation. This situation is called indirect proof, or IP. Here's what you do in this situation. So this is another theorem. When you get stuck, none of these other things apply, you do this. You provisionally assume the contrary of your goal, so whatever your goal is, but not that thing, and then you get any contradiction. What is a contradiction? A contradiction is any statement and its contrary. So something plus its opposite. So we're going to try and get that. So first of all, let's start with this. Provisionally assume the contrary of the goal. So what's the goal? The goal right here is A. So what we're going to do is we're going to provisionally assume in line 3. So all provisional assumptions we indent, it's a side quest. We're going to provisionally assume the contrary of our goal. Our goal is A, so it will be the contrary of A, or the quote-unquote opposite of A, squiggle A. And that is a provisional assumption. And the goal now is get any contradiction. Anything plus the same thing with a squiggle in front of it. That's what we're going to try and do. That's what a contradiction is. So the way indirect proofs work, so this is what we're starting here in indirect proof, is the last move in an indirect proof is always 100% of the time an and in. We say something and not the exact same thing. So that's the goal. We do that, we can prove that this is true. So let's try this. Now with this squiggle A in place, this provisional assumption of the contrary of our goal, now go back to the regular order of business. Can I do an arrow out now? And in fact, I can do two. Right? This is the left side of both of these. In fact, I get B, arrow out, 1 and 3. And I also get squiggle B, arrow out, 2 and 3. Great. I get both of these from this. Now let's go back to our list. Can I do another arrow out? All the arrows are done. Can I do a modus tollens? Do I have the opposite of right side somewhere? Actually, I do, but I don't need to do that. I'm going to explain why in a moment. Can I do an and out? No, there's no dots to and out. Can I do an and in, and should I? The answer here is yes, and here's why I didn't do the modus tollens here a moment ago. Because the goal, once you start an indirect proof, is get any two things that are contraries of each other. Or like I said, opposites. Technically, opposites is not accurate, but we can go ahead and roll with that. Get any two opposites, any two contraries, and stick them together. Do I have any contraries? Do I have any opposites? So look, B and not B. These are contraries of each other. B and not B. So what I'm going to do, like I said, the way an indirect proof works is once you start provisionally assuming the contrary of your goal is to get any two contraries and stick them together with an and in. That's a contradiction. So I've got two contraries. These two things, I've got something, and I also have the exact same thing with a squiggle in front of it. Those are contraries. So a contradiction is where you stick those two things together with a dot or with an and in. So that's what I'm going to do. I'm going to say here, line 6, B and squiggle B, and in 4 and 5. So mission is complete. I said here, all right, let's provisionally assume that A is not true. The goal now is to get a contradiction, get any two contraries and stick them together. We did that here just now in line 6. So when that happens, what that means is you can zoom out and say, hey, the thing that we provisionally assumed, this thing, let's pretend this thing is true. A is true. How? It's true indirectly. Indirect proof. Where did it start? Where do we provisionally assume the contrary of our goal? Line 3. Where did we get a contradiction? Line 6. So here's what's going on here. Here's the way an indirect proof works. Here's what you're saying. All right, we got these things. We want to get this thing. How can we get there if these other things are not working? So here's what you say. Let's pretend that the thing that we actually want is not true. That's what this squiggle is here. The thing that we actually want to get, let's pretend that it's not true. And let's see if it leads to nonsense. So what this is here in line 6, this is nonsense. We're saying something is true and its opposite is true. That's like saying today is Wednesday and it's not Wednesday. That's stupid talk. So what we're doing here in an indirect proof is we're saying this. If we want to prove something, let's just for the sake of argument say that its opposite or its contrary is true. If that leads to opposites being true together or contraries being true together, if that leads to contradictions, that means this thing is stupid, which means that this thing is true. That's how an indirect proof works. Now, you've done this before. If you've ever had like an argument with a friend and your friend says something, you're like, wait, if that's true, then that's like saying, and then you come up with something ridiculous, you're doing this. You're saying, hey, I'm right. Because if you're right, it means that this thing is true that's stupid. And this is stupid. Contradictions are stupid. It can't be both Wednesday and not Wednesday. 2 plus 2 cannot equal 4 and not 4 in the same axiomatic domain. Like, that doesn't make any sense. Okay, it can in other contexts. But you're saying, all right, like, if what you're saying is true, then it leads to this situation where something is true and its opposite is true, and that's stupid talk. That's what's going on here in indirect proof. This is true because if it's not, it leads to absurdity. That's why this is also called a reductio ad absurdum. Same thing. Sometimes we can use modus tollens to skip this altogether. Here, there was not an option to use modus tollens. Okay, as such. There was here early on, but it just would have repeated stuff that we already got. So for example, here, if we said, oh, I've got squiggle A, and the opposite of its right side, we've got B, its opposite of its right side would be squiggle B. Oh, I can get B. Well, that's something that we already had. That's why I was avoiding doing that. That wouldn't be anything new.
Okay, so that was an introduction to the rules that we can do with negations, double negation, modus tollens, indirect proof. What I'm going to do in the next video is I'm going to go over some sample problems from the book that are practicing these new rules. See you next time.